which is replace chalk. So here's a question. So you're given an array of n students, and each student needs a certain quantity of chalk to solve a problem. So the teacher assigns the problem from left to right of the array, and as we go from the left to the right of the array, the size of the chalk available will be reduced based on how much chalk is required by each student. So it'll be continuously removed. I mean, the size of the remaining chalk will be continuously reduced by the time we go towards the end of the array. And by the time at the end of the array, if the chalk isn't fully used up yet, then you start from the beginning of the array again, which means chow 0 answers the question using the required chalk for the first element in the array. So the question is to identify where the chalk will need to be replaced, which is simply that where the size of k will be lesser than 0. So here's the question. So let me go through a run through of what the scenario could be. So at the start, you start off with k equals 22, which means you have chalk of size 22. After the first student answers the question, the size of the chalk k reduces to 18, which is 22 minus 4. And then after the following question, then 18 minus 7, which cost 7, is the chalk required by the second student. So it's 18 minus 7, which will become 11. So now we have 11 pieces of chalk available. So this process will continue on, and until the size of k is less than 0. The thing is, we could simulate the whole process, but this might be too slow. For example, in this case, we could go down after 11 to 8, and then to 6, and then to 2, and then when we go to the second person in the array again for the second loop, we realize that k is already minus 5, which is less than 0, which means that person 2 would have had to replace the chalk. Is there a faster way of doing this rather than simulating the whole process? Yes, we don't need to manually loop through again and again, as we notice one thing: the array does not change. Every single time we go through the same elements in the array, nothing changes. Also, what if k was very high? How will we know exactly where the loop will stop? Thus, it is key to identify that it is not important how many times the loop completes running. It is only important to identify where it stops. It doesn't matter how many rounds of the array we complete, or how many sets of questions are being answered. The only important factor is where the chalk gets run out. So, what we can do is to get the maximum chalk used by the end of one run of the array, which means one set of questions from chow 0 to chow n minus 1, and then we divide k, which is the initial maximum amount of chalk available, by this maximum sum and get the remainder. So, what can we do with the remainder? The remainder is how much chalk will be used up in the current run, as in the run in which the chalk is definitely running out. We can use where it stops to determine who changes the chalk, as we discussed earlier in that earlier example. So we also need a quick way to identify where the remainder ends. Because let's say if we don't have a quick way to do that, we need to keep a rolling sum of the array as we try to find where the remainder ends. So here's where the concept of a prefix sum array comes in. It is a sum of the elements in the array up to the point I, up to the index I. Let's see an example here. So if an array of elements 4, 7, 3 and 2, and in the prefix sum array we set the first element to be 4, which is the first element in the array as well, and then for the second element in the prefix sum array, note that this is the sum of the elements in the array up to the first index, so it will be 4 plus 7, which will become 11. As also for the second index in the prefix sum array, in a similar vein, is a sum of elements from 0 to the second index, which will be 4 plus 7 plus 3, which will give us 14. As you can see, a simple way of looking at it is also could be that the prefix sum array takes the sum from the previous index and adds on the value in the actual array. So we don't need to keep large sums in counting as we calculate the prefix sum array, and you can just add on the current element in the array to the last element in the prefix sum array as you create the prefix sum array. So yeah, so at the end we do get 16, which is the sum of 4 plus 7 plus 3 plus 2, or simply put, just 14 plus 2. So how do we find the answer? So we're given this prefix sum array 4, 11, 14 and 16. So now we know that for every loop of questions, which means for every set of questions from the first to the fourth child, the maximum chalk that we used up will be 16. So from this we can kind of know that if we divide 40 by 16, we get a numerator 2, which means that there will be 2 complete runs of the array of the questions completed. You will complete 16 and another 16, leading up to 32, which will give us a remainder of 8. So this suggests that the remainder is 8, and we now need to find in the prefix sum array where the chalk will be 0, as in where 8 will happen. The good thing of the prefix sum array is also the fact that it is monotonically increasing and it's is sorted, so we can simply just iterate through the array and find a value where it begins to be greater than 8 or whatever our remainder could be, and that would be the place where the chalk runs out. So yeah, so here 8 is smaller than 11, and thus we know that index 1 will replace the chalk. So let's go through the code to solve this problem. So first we need to create the prefix sum array, and we initially set it to be chalk 0, which is the first value in the input array. And we iterate through the input array from the first element to the end, from the second element to the end of the array, and we add that element along with the last element in the prefix sum array to get the prefix sum up to the ith index. So this, at the end of this operation, we would get our prefix sum array. Also, now we can get the maximum value, which is the last element in the prefix sum array, as it is the sum of all elements in the array. And we get our remainder, which will become k remainder sm. And now, as explained earlier, you can just go through the prefix sum array, and then if the element is greater than the remainder, then you return the index, which means that that's the index where the chalk will be replaced. So let's go through the time complexity and space complexity for this question. So for time complexity, note that we're only running through the array in linear time, so it will be O of n. For space complexity, we are generating a prefix sum array of size n, so the space complexity will be O of n as well. That is the end of today's question. Thanks for watching.